In this lesson, we're going to find the Maclaurin series for the function f of x equals e to the x. Remember that we derived the formula for the Maclaurin series for a function f of x. So Maclaurin series just means Taylor series centered at 0. So f of x is sum n equals 0 to infinity c sub n x to the n, where the c sub n's are given by this formula that we derived. So I'll go ahead and put in our formula. So we have f of x is going to be sum n equals 0 to infinity. The c sub n, so that was nth derivative of f, evaluated at 0 because it's a Maclaurin series, over n factorial x to the n. And if you prefer to write out the term, so this means f of 0 plus f prime of 0 over 1 factorial times x plus f double prime of 0 over 2 factorial x squared plus third derivative, so third derivative of f at 0 over 3 factorial x cubed, etc. So this is what we're looking for, so we need to figure out what all these derivative values are equal to. Now I do this by setting up a chart, so I say n, and then the nth derivative of f, and then I'm going to plug in my a value, which in this case is 0, because we have a Maclaurin series. So my chart, my sum starts at 0, so my first n value is going to be 0, and so then I just want the 0th derivative of f, that just means the function itself, which is e to the x. And e to the 0, when I plug in 0, I get 1. Now I jump to n is 1, so I want f prime of x, the derivative of e to the x is just e to the x, again I plug in 0 and I get 1. Now n is 2, so the reason I use the chart is because now I need the second derivative. To take the second derivative, I just want the derivative of the first derivative, which is the previous function in my chart. So derivative of e to the x, just e to the x again, plug in 0, we get 1. And of course this is going to continue. So for e to the x, the derivatives are all e to the x, and then we just, every time we plug in 0, we get 1. So what we figured out from our chart here is that the nth derivative of f evaluated at 0 is equal to 1 for all n. So our nth derivative of f at 0, this right hand of our chart, is always going to be 1 because we just keep getting e to the x for our derivatives. Which tells us when we go to plug into our formula, so our series for e to the x, we get sum n equals 0 to infinity. Nth derivative of f evaluated at 0, we just got 1 over n factorial x to the n. So e to the x, as the Maclaurin series for e to the x, is sum n equals 0 to infinity x to the n over n factorial. And if we write out the terms, this is 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the 4 over 4 factorial, etc. And this just goes on and on. The way this is used in practice, so suppose you need to know the value of e, for example, so how are decimal approximations of e constructed? So you can simply plug in x equals 1 to get e. You would get 1 plus 1 over 2 factorial, 1 over 3 factorial, plus 1 over 4 factorial, etc. And you could on your computer say add up the first 1,000 terms of that series, or first 10,000, first billion, etc. terms to get a decimal approximation for e. So again, this was an example of computing a Maclaurin series. I recommend that you set up a chart, so you need n, nth derivative of f, and then plug in your a value, which in this case was 0.